In this lesson, we're going to discuss direct, inverse, and combined variation. In each of these cases, there's a constant k, which means it's called a constant because it's going to be a number that never changes. It's not going to be a variable. And then x and y can be the variables in the equation, but k is going to be some number that stays constant. In each case, you have to be able to read a sentence that talks about varying inversely, varying directly, varying jointly. Those words will mean a certain equation automatically. So if you see something that says y varies directly with x, that's when you put y equals k times x. And that's just automatic. As soon as you see those words, y varies directly with x, you write y equals kx. Then if you see the words y varies inversely with x, then you put k over x. And it's very important that the x is on the bottom, not the k. And then when you see something like varies jointly is just a direct variation but with two things. So y varies jointly with x and z. Both of those are being multiplied. And then they also can say in the same one and inversely with w. So that would just put w on the bottom. But k is going to always be on the top or to the side of the letters, but never on the bottom. So let's look at different examples and how they might read. And these are just simple examples, and I look at these in a three-step process. And it kind of comes in three sentences or phrases. And the first one is y varies directly with x. That helps you set up your equation. Y varies directly with x. So as soon as you see those words, you write that equation. Then the second sentence helps us to find our k, because a lot of times they don't tell you the constant of variation, but they give you some numbers that will help you find the constant of variation. So what I'll do is I'll put in, it says when x is 10, y is 5. So we'll put in y is 5 and x is 10. And if we have that information, we have enough information to figure out what k is. So we'll divide both sides by 10, and we'll get k is 1/2. So that's kind of step 2, is find k. Step 1 is just write which equation it is. Step 2 is to find k. Step 3 then is to go to what they're asking for. They say find y when x is 4. So now that we have the constant of variation, we keep that constant for the rest of this problem. So 1/2 is now that constant of variation, and then we have a 4 for x, and they say find y. So now we have enough information to find y in this scenario, and we get y equals 2. So the answer to the question is 2. In our second example, it's the same three-step process. It's just you start with a different equation because it says y varies inversely with x. And so immediately we know to write the other equation that has k over x. And then we fill in the numbers to help us find k. So when x is 10, we'll put 10 down here. Y is 5, so we don't know k. And we can solve for k by multiplying both sides by 10. To get k by itself, we'll multiply both sides by 10, and you get k equals 50. So that's step 2. Step 1 was just to write the equation. Step 2 is to fill in what you know, to find what you don't know, which is k. Then step 3 is to write what you know. In the last sentence, find y when x is 4. So we now know k is constantly going to be 50, and x in this scenario is 4, so they want you to find y when x is 4. And so we end up dividing that in 4, and we get 12.5 for y. Lastly, we have what we call a combined variation because it's got direct variation and inverse variation going on in the same problem, so it's a combined variation. And it says y varies jointly with x and z, so y varies jointly with x and z, which means direct. It just means direct, it varies directly with two different variables. And inversely with w, so inversely with w. So that has to go on the bottom. So let's see what we know. So what we have is when y is 6, x is 3, z is 1, and w is 12. So I put each number in the right spot to replace the letter. K is the only thing we don't know. And this is k times, if we do 3 times 1 over 12, we get 1/4 reduced. And then to get rid of the 1/4, we would multiply both sides by 4. Multiply both sides by 4, or divide both sides by 1/4, depending on what method you use. Multiply both sides by 4 or divide both sides by 1/4. And in that either case, you should get 24 for your k. So here's our step 1. Step 2 is to plug in everything you know to find k. And then step 3 is to fill in the last sentence, find x, and this time it doesn't say find y. They can ask you to find anything, and in this case they ask you to find x, but just plug in everything else and it'll work itself out. So it says find x, so x is going to be the thing we don't know this time, when y is 4, when z is 2, and when w is 0.5, and we also had the k that we could fill in now is 24. And so the only thing we don't know is x, so if we simplify the right side, we have 24 times 2, which is 48, and if you took 48 divided by 0.5, you would get 96. And then there's still an x there. Divide both sides by 96 and reduce, and you will get 1/24 when you reduce it. That would be 4/96, which reduces to 1/24. So that's finding x. So you can find whatever letter they want you to find as long as you have enough information on all the other letters. Lastly, I want to look at the differences between their graphs with direct variation and inverse variation. Basically, direct variation is just linear. It's a line. If you think about it, it's kind of like y equals mx plus b, where b is always 0. And so this is like your m in y equals mx plus b, and m is the slope. So your k in direct variation is exactly like a slope. You start at 0, 0, since your plus b would be plus 0, and then you rise 1, run 3, rise 1, run 3, and so on. And you end up with a line that looks something like this. So that would be direct variation. When it's positive, it will go in a positive direction for the slope. When it's negative k, that just changes the direction of the line to where you still start at 0, 0, but you go down 1/3, down 1/3. And it ends up being a line that looks something like this, that has a negative slope. And so it all makes sense when you think about lines. This is just like any line that we've ever graphed before. Now, the inverse variation is what we call a reciprocal function. That's just the name for it. This is a reciprocal function. And let's look at how that looks. When it's positive on top, and it's a reciprocal function, you'll find that it ends up graphing in these two quadrants, the first quadrant and the third quadrant. And when there's a negative number over the x, it will end up graphing in these two quadrants. And it does curve, and it also does not touch the x or the y axis. And so the x-axis acts as an asymptote, and the y-axis also acts as an asymptote. And of course, these things could be, you could add something or subtract something, and these would transform, and the asymptotes would move with the graph. But you need to know what the general shape is of an inverse variation, or a reciprocal function is what these are called. And we'll go into that more when we get into reciprocal functions. But that's the general shape of direct variation versus inverse variation.